Hey, and welcome to this demo showcasing how Cisco, Isovalent, and Splunk come together to better protect your switches. If you have any questions after, feel free to reach out. And thank you, of course, to our friends and colleagues on the Splunk and Cisco Nexus team working on this with us. Over the next 5 to 10 minutes, we'll demonstrate how security and SecOps teams can mitigate specific CVEs on Nexus switches using the Isovalent and Splunk integration. So, as you can see here, we have our Splunk dashboard open to our pre-built CVE mitigation on Nexus switches dashboard. So this is focused on Nexus 9000 series switches, but let's go ahead and get started and dive into some of the widgets. So on the top left, here you can see which Nexus switches are affected by CVEs. For this demo, we only provision one switch. This is NXOS 9K. Then over here on the right, this widget displays a timeline of CVE exploit attempts that were blocked by the Isovalent Tetragon enforcement policies. For example, you can see that the CVE is blocked at 2 p.m. on this attack timeline, and we'll dive into those CVEs down below. So, here we'll get more specific details on those alerts triggered by Tetragon when those CVEs were blocked. Kind of a fun note, neither of these CVEs are really exploitable in the wild. The second one we actually just created for this demo. Obviously you can see CVE 2030-9999. So maybe in about 5 years or so, you'll see this CVE pop up or something. And then for the first one, this is an older CVE, so most kernels are actually already patched to this one. But what's really fun about this section is we get that first taste of the rich metadata for all those alerts that Tetragon can surface up through Splunk. So this includes details like the process ancestry, the binary path, the user IDs, and the arguments used during execution. So this metadata gives us a really deep forensic understanding of what happened, where, and provides that valuable context for mitigation and analysis. So let's take a look at that first one. So this is a dirty cow exploit CVE 2016-5195 that was blocked by Tetragon. And here in the Splunk dashboard, we can start to see those details of what happened and where. So the exploit originated from the TMP dirty cow exploit binary, parent binary, and executed with the user ID 2002. Like I mentioned, most kernel distributions have already been patched against this vulnerability, but Tetragon provides that added layer of protection. In the second one, we have a fake privilege escalation vulnerability. Here we labeled it as CVE 2030-9999, and this would target the admin CTL binary. This is a obviously fake privilege escalation vulnerability, and we've created it to affect the SUID binary admin CTL. For those of you unfamiliar, admin CTL is a set user ID root binary. And this means essentially that it always runs with root privileges regardless of the user executing it. So this binary can be triggered to overwrite privileged root-owned files when saving the machine state. So we've installed a Isovalent Tetragon enforcement policy, which would mitigate against the CVE by stopping and killing. Here we can see the action taken as kill. So this would kill the admin CTL binary execution when it's coming from an unprivileged user. So here we can see that the alert shows the VAR volatile TMP admin CTL binary from this unprivileged user ID of 2002 was killed. Now this is interesting, but let's get a little more information on the parent binary on the process tree itself. So let's dive deeper, and what we're going to do is we're going to open up our process tree for the workload. So I've already pre-configured this to go into the specific time frame that we care about, the date and time range. And here we're going to look at this preloaded tab with the time window we care about. So we can see that the process tree for that time when the two alerts were fired by Tetragon, and we saw the same exact information down below in the Splunk dashboard. This is just presented in a different way as we get to see the full ancestry of what happened on this workload. So what we care about here is two things, and we're going to talk about one for each CVE. In the process tree itself, we can see the SSH process DCOS SHAD as a parent process on the Nexus switch. And what this means is there was an SSH session initiated to the switch. The first couple of child processes here, we can see via VSH are really representing that default shell that is running on the Nexus switch. Then we have this bash child process, and this is where things get more interesting with the initiation by the attacker. So, as a first child process under bash, we can see the dirty cal exploit binary, and this is that same binary that we looked at in the previous dashboard that exploits the vulnerability CVE 2016-5195, and which was blocked. For obvious reasons, there's no child processes beyond this because the process was killed. Underneath bash again, where the attacker initiated, we can see the second attempt on the admin.ctl binary. So here we see the admin.ctl binary with the arguments save state run admin.ctl trying to affect the etc password argument. The attacker ran this a few times, trying to modify the save state of this sensitive file. And what we see here is Tetragon detects that it's a non-privileged user and blocks the event from executing and modifying the etc password file. So after seeing that process ancestry tree, I just want to move back to the main dashboard for a moment before we close out and show you two additional sections that focus more on the alerting use cases versus the enforcement use cases we just saw. As you can see through that process ancestry tree and through the Splunk dashboard here, what Tetragon was doing through those policies was actually taking action and blocking the events from executing. However, if you have a set of policies where you want to generate informational alerts or warning alerts, Tetragon can also do that on Cisco Nexus switches and surface that through a Splunk dashboard here. So in this demo, what we did is we assigned a variety of different policies, different levels of severity ranging in warning to informational. And here we can see that there were 58 warning alerts we generated and 349 informational severity alerts. Thank you so much for being with us the last few minutes, and I hope this helps demonstrate how Isovalent, Splunk, and Cisco are really coming together to support security and SecOps teams, and really helping visualize and mitigate CVEs effectively on Nexus switches. If you have any other questions, please feel free to reach out. We love talking about this stuff, and we'd love to show you more. Thank you so much, and enjoy the rest of your day. Thanks.